Hello students, in this video we are going to discuss about dark reaction of the photosynthesis. As I told you previously, photosynthesis comprises of two phases. Number one is light reaction and second is dark reaction. In this video, we will learn about dark reaction. This is a biosynthetic phase of photosynthesis in which ATP and NADPH that form during light reaction drive carbon dioxide fixation and reduction to produce sugar. This process does not directly depend on the presence of light, but it depends on the products of the light reaction. So dark reaction is also called as light independent reaction because they does not depend on the presence of light, but they depends on the products of the light reaction like ATP and NADPH. Dark reaction, also known as black man's reaction. Dark reactions were represented in the form of cycle called Calvin cycle. Now we are going to explore Calvin cycle. In this cycle, the enzyme Rubisco captures carbon dioxide from the atmosphere and uses the newly formed NADPH and releases 3-carbon sugar, which are later combined to form sugar and starch. The equation of the overall Calvin cycle is shown diagrammatically below. By the equation, it is clear that synthesis of one molecule of glyceraldehyde 3-phosphate, or we can also say as triose phosphate, from carbon dioxide require 6 molecule of NADPH and 9 molecule of ATP. Now we are going to discuss overview of Calvin cycle. This is the Calvin cycle. Calvin cycle divided into 3 phases. Number 1 is carbon dioxide fixation or carboxylation. Second phase is reduction, and their third phase is generation of ribulose 1,5-bisphosphate, which continue the next Calvin cycle. Calvin cycle also called as C3 cycle because the primary product of this cycle is 3 carbon containing. In the first step of Calvin cycle, the enzyme Rubisco catalyzes the carboxylation of ribulose 1,5-bisphosphate by carbon dioxide and forming 2 molecule of 3-phosphoglycerate. The key enzyme of this cycle is Rubisco. In the next step of the Calvin cycle, the enzyme phosphoglycerate kinase catalyzes the phosphorylation of 3-phosphoglycerate into 1,3-bisphosphoglycerate by ATP. In the next step, 1,3-bisphosphoglycerate reduces to glyceraldehyde 3-phosphate by the enzyme glyceraldehyde 3-phosphate dehydrogenase, and the NADPH itself is oxidized and become NADP+. Next step of the Calvin cycle is the regeneration of ribulose 1,5-bisphosphate. 5 glyceraldehyde 3-phosphate molecule produce 3 ribulose 1,5-bisphosphate molecule using up 3 molecules of ATP. Thus, out of 6 glyceraldehyde 3-phosphate produced during Calvin cycle, 5 are used to make 3 ribulose 1,5-bisphosphate molecules and only 1 glyceraldehyde 3-phosphate available for subsequent conversion of glucose and hexose. So, by this step, ribulose 1,5-bisphosphate is generated, which continue the next Calvin cycle. Now we are going to discuss overall biochemistry of photosynthesis. As shown in equation, for the synthesis of 1 molecule of glucose from 6 molecule of carbon dioxide, it requires 18 molecule of ATP and 12 molecule of NADPH. This is all about dark reaction of photosynthesis. Thank you.